Okay, welcome to the video. Here's the problem we're looking at. Again, we've got a probability distribution table here telling us if we randomly select a student from among those who were surveyed, what's the probability that the student we randomly select is within each of these age categories. So either when they gave this survey, they just had the students check a box, yeah, I'm between 15 to 17 years old, or I'm between 18 to 24 years old. They might have done it that way, or the student might have actually reported their true age, but then when they were organizing the data, they broke it down into categories to make it a little easier to look at. So now let's take a look at the actual question they're concerned about. They're saying based on this data table, they want to know that if they choose a student at random, what's the probability that student is going to be between 18 and 30 years old? So if we look at our table, so here's what we're looking at, 18 to 30 years old. If we look at our table, well, we've got the 18 to 24-year-olds here. And we can say there's a 22.6% probability that someone would be 18 to 24. So the probability that they'd be 18 to 30 should be at least that big. But we need to include all the 24 to 30-year-olds. Well, to find the 24 to 30-year-olds, we're going to look in this category. Here's where we start to run into a problem. This category is students aged 25 to 34. And we see there's quite a lot of students in that category. 49.5% of all the students are in that category. But here's the problem that we're encountering. We don't know, of those 49.5% of students in this category, how many of them were under 30 and how many of them were over 30. It could have been that all of them were 33, in which case the number of students between 18 and 30 would just be this. But it could be that all of these 25 to 34-year-olds, everybody who checked that box, was actually 25, in which case the 18 to 30-year-olds would be this number plus all of this. In reality, the most likely case is that some of these students were under 30 and some of them were over 30, but we can't make any assumptions about how many would split in each category. It could be that it splits half and half, but it might not be the case. So what we see here is kind of one of the dangers of collecting data in a categorical fashion because it determines those categories and later we can't get more information back out. So if you were designing the survey, you might say it would be more helpful to actually ask the students for their ages and keep that raw data somewhere so that if later on you decided, well, the age category I'm really interested in is 18 and 30, you could go back and find that information out from the raw data. Because a table like this that has the categories already set up in a different way will not provide enough information to answer that question. So there's kind of the big world picture. How are we going to answer that WAMAP question? Well, here's the information we need. It says type the word impossible if there is not enough information provided. So that's what we're going to need to do. We're going to go ahead and in our answer block type in that word impossible because there's not enough information on this table to answer this question.